All right, here we go. Today we're going to be looking at finding a solution of a system. Now, in previous lessons, we found out how we could do this by graphing, right? You can get each equation, you can graph each equation, and you can find out where they cross, right? This looks no different from what you have done in previous nights, right? You've got two equations. Each one has a y and or an x. Both of these have both. And so you should be able to, therefore, if you wanted to, rearrange these. You could create two equations, one or two lines, one which would look something like this, and the other which would look something like this, and then you could find out where they cross, obviously. Okay, now, yes, you could do that, but we talked about in class some of the disadvantages to that. The disadvantages are, well, if your graph isn't perfect, your point's going to be off. Number two, nobody really likes graphing anyway. Yes, it's visual, it's nice, that's why we do it, because it's a nice visual, you can see it. But at the same time, we would love to have another way of not having to graph it. Okay, also, if this crossed at a decimal, there's no way to know if something's crossing at 5.5 or 5.53, and so you can't really get an exact answer for those fractions and decimals. So we would like another way to do this. So that's what we're going to do. We're going to talk about a way called substitution. Okay, now it's called that because that's exactly what we're going to do. We're going to substitute. So what we do is in one of the equations, it doesn't matter which one, but in one of the equations we get a variable by itself. Okay, it doesn't matter which variable, just any of them. Now, in this one right here, the y is already by itself here. So that's step one. Done. Step number two, we're going to substitute in the other equation. Okay, now that's important that we do it in the other equation, because if you substitute back into itself, everything's going to disappear and go away, and you're going to be completely confused. So what we're going to do, we're going to take this 2x plus 1. 2x plus 1 is equal to y. Now, if 2x plus 1 is equal to y, that means that y can be substituted with the 2x plus 1. So in this other equation, anywhere where I have a y, I'm going to write 2x plus 1. So I'm going to rewrite this equation now as 3x. I'm copying it down exactly as it is here. So I've got a 3, I've got an x, I've got a plus. Now when I get to the y, instead of writing y, I'm going to substitute it with 2x plus 1. And like a good little Algebra 1 student, anytime I substitute, I put it in parentheses. So then I've got equals, because the equals would come next, and negative 9. Now, you'll notice that magically, okay, so it's not magic, it's just algebra. Magically, the y is now gone. The only variable I have is x. And so this actually becomes quite easy. Now, I'm not distributing because it's just a plus. If you want, you could say, okay, well, the plus is going to distribute to those, which makes it 3x plus 2x plus 1. But we actually learned back when we were putting polynomials together that when you had a plus in front of parentheses, you could really just get rid of the parentheses. And it's exactly that, because you're taking that plus 1, essentially, and distributing it to everything. So from there, we can put the like terms together. So we've got 5x plus 1 equals negative 9, and I solve for x. I subtract the 1. That's the reason why we learned how to solve linearly for a single variable earlier. So we just divide by 5, and I've got x equals negative 2. Now, that's not the answer. Remember, the solution of a system is the point where it crosses. The point requires two pieces of information. It requires an x, and it requires a y. And so we're going to need to now solve for y. So we've done step 2. Step 3 is solve for the remaining variable. And then we have step 4, which is solve for the other variable. Now that should be pretty easy because now we have an x value. We know that these two lines cross when x is negative 2. And so we can take this x equals negative 2 and plug it into either equation. It doesn't matter which one. You can put it into either one there. Now, again, in step 1, we got a variable by itself, and we said get the easiest one. Okay, so again, when we're solving for the other variable, we're going to put it into the one that looks the easiest. Well, it looks easiest to get y in this first equation, because y is what I want. So I'll go y equals 2 times x plus 1. And so then I'll have y equals negative 4 plus 1, so y equals negative 3. So now I have my point, which is negative 2 comma negative 3. My answer should always be written as a point because it is the intersection of those two things. Unless it's a word problem, then I can say, well, this is 2 hot dogs and 3 hamburgers. But in any other situation where I'm just dealing with numbers, you really should answer as a coordinate because that's what you're finding is the solution, the place where those two lines cross. Okay? Now, the last thing that we should do, as we should do in any problem, is to check our answer. Okay? So to check our answer, we're just going to take the x and y, and we have to check it in which equation? In both equations. Why both? Because if it's the solution of the system, it has to work in both of them. So I'm going to take the first equation. I'm going to go negative 3 equals 2 times negative 2. Now I'm pretty sure this one's going to work because I just did it. But negative 3 equals 2 times negative 2 is negative 4 plus 1. Okay, that works. Now I'm going to check out the second equation. So I'm going to go 3 times x plus y. Again, notice that every time that I put a variable, a number in for a variable, or anything in for a variable, anytime I substitute, I'm putting in parentheses, equals negative 9. 3 times negative 2 is negative 6, plus negative 3 equals negative 9, and negative 6 and negative 3 is negative 9. That's a check. So this is the correct answer. So there you go. That's how you solve using substitution. Watch the next video, please, for the next one more example.